Hi class, this is PEP288 Motor Learning and Performance with me, Elizabeth Harding. I'm going to go over some of the calculations for Lab 2, error scores. So here is our class data set. It's looking quite good. Some of you have already filled in all of your data, including your absolute, constant, and variable errors. So what I would do in order to work with this, so your assignment, aside from being responsible for getting your own data onto your own row, is to create graphs and answer some questions about the entire class data set. So we have approximately 60 participants. So what I would do in order to make this just a little bit more manageable and also just to protect our class data sheet is just make a copy. So you can either highlight all the cells of interest, etc., Control C, but I would make a copy of this data set or copy the data into your own or a brand new Excel workbook. Maybe you store that on your desktop just for a little bit or in a special place where it can be easily accessed. So what I've done here, this isn't necessarily our class data, but this is a good example. I have 10 participants. You'll have more than 10. And I have my toss condition 1, as you can see, toss condition 2, and toss condition 3. So one thing that I did, actually the first thing I did, was I added 5 new columns of data to represent the absolute error. So you can definitely create a formula in Excel to calculate each absolute value and total that all up, divide that by the number of trials to get your absolute error, but it is very cumbersome and can be very frustrating, especially if you forget a parenthesis or two. So I decided that it's just better to, or at least easier for me, to go ahead and create new columns of data. So if you're not as familiar with Excel, a very easy way to do this, I need 5 new columns. So I would just highlight the 5 new columns next to, and then right-click and insert, and voila. 5 new columns, and then I would just add my headers. Okay, so we don't need those, so right-click, delete, and of course Command Z or Control Z or this back arrow, right, to undo anything in case you get a little overzealous with the delete key. So I'm just going to use the cell. So very easily, I know that the absolute value of 14 is 14. But things can get transposed incorrectly if I were to just hand type all of this data. So I'm just going to use the absolute value formula in Excel. So equals ABS, highlight that cell, hit return, and there you go. And I can just drag this over, right, and Excel knows, and I can drag it down. And there you go, my absolute values, and everything looks correct. Just kind of give it a glance over. All right, so now I'm going to calculate my absolute error. So the formulas for absolute error that I gave you in class, or the formulas for all of our error scores that I gave you in class on Wednesday, are right here. So absolute error is the sum of all of the absolute values for errors, of our errors, over the number of trials. So it's an average. So to make it easy, I am just going to use the average function in Excel and take the average of my absolute error scores. There you go. And then I can scroll or take this all the way down. And there's my absolute error. So now constant error, looking at our formulas, constant error is the sum of the raw error scores. So taking into account the direction, the plus or the minus, over the number of trials. So going back to Excel, equals the average. So these raw error scores here, 5 trials worth, and there's my constant error, dragging it down. Okay. Now variable error gets a little trickier, especially if you are trying to do it by hand. So let's take a look at this. Now, if you remembered from test and measurements or from your basic stats class, you might notice that variable error is the standard deviation. So the sum of all of the raw error scores in each of these error scores is squared, summed together, divided by n. So what you might not remember is why we subtract 1 from the denominator. Now, I didn't necessarily go into this on class. I believe the formula I gave you was just straight up over n. This is the formula for the standard deviation of a population. We are dealing with a sample, and so since we're just making an assumption about a population, we're going to subtract one of our trials. And what that does is it makes our denominator smaller, which is going to magnify or make our variable error larger. And why we do this is because we want to eliminate any bias we might have about our experiment or about our results. So we magnify that error so that if something is statistically significant, we can say fairly confidently that we are correct in our hypothesis. But here is a formula for variable error. But like I said, the variable error is essentially the standard deviation of a sample. So we're going to use that formula in Excel. So stdev.s. So you can see actually I have two functions here in Excel, a .p for population and a .s for sample. And then I'm going to select my raw error scores. And I have my variable error. So what you're going to do for your lab report is you're going to take the average absolute constant and variable error. So for all of our, I think, 58 participants, we might be missing one or two, so just keep that in mind when you're cleaning up your data sets. So the average absolute error for task condition 1, the average constant error for task condition 1, and the average variable error for task condition 1. All right, so I've already calculated the absolute constant and variable errors for task conditions 2 and 3. So now let's move on to the fun part, which is making a chart. So the reason why I set it up this way was because I wanted your data sheet, right, or the instructions on your lab say that you're to create a bar graph displaying the overall average score in inches on the y-axis. So that vertical axis will be your error scores, and each task conditions 1, 2, and 3 on the x-axis. And so by setting it up in a table like this, I can highlight this table, and Excel is going to treat each one of these task conditions as a series. So if I go up here, insert chart, do not use spark lines. It's a column. There we go. Okay. All right, there we go. So I have my task condition 1, task condition 2, task condition 3. Blue is absolute, orange is constant, and the gray is variable error. Okay. So there are, in fact, 3 separate graphs here. They just happen to be on one chart. And this tells a much better story. It's a lot easier to get through than if you were to have actual 3 separate charts with, your constant, absolute, and variable error for each condition, right? So if this represented the absolute error of task condition 1, etc. So I think that this tells a better story, and it makes it easier to, say, answer questions 1 through 3, where you're comparing the differences in error scores. So a couple things not complete. So for my class, and if you had me for test and measurements, you will know that I am adamantly opposed to any kind of chart title above the chart, right? So for figures, like a chart, we always put a caption underneath. But what you do need is some sort of, information here on the y-axis. We already have our x-axis pretty well labeled. We have a nice legend over here which tells the reader, or me, since I will be your reader, what's happening. We do need to add a y-axis. So if I just highlight, let's see if this works to format axes, possibly. No, I don't like that. What if we were to, let's see here. I just forget where it is. Chart layout. So we go to chart layout, and we can see we have axis titles. I'm going to the vertical axis title. Rotated's nice. And I'm going to enter, let's see here, error score. That looks good. And then the units. So we measured in inches. That looks good. And that's it. One other thing that you actually can do here, and this is just me getting fussy, and I'm sorry that I'm putting you through this right now, is clean up some of this white space. So check your maximum and minimum values. So we can go as low as 14 here for our maximum value. Just makes it look nicer. Okay. So there you go. And then you get to tell me an awesome story about what happened and what you noticed. And that's it. All right, if you have any questions, please email me. Thank you all very much for your patience and flexibility during Friday's lab. All right, have a great weekend.